So the next question in the series is running sum of 1D array. So this will lay a good foundation for prefix sum pattern. So in this, what we are given is we are given a nums array and we need to define a running sum of the array. And running sum is equals to, for example, if let's say we have 1. So at index 1, the output will be 1. At index 2, output will be sum of first and second index. Similarly, we are adding the element which is coming, and this is called running sum. So if we look at this, what we have is at index 0 we have first element sum only. At index 1 we have 0 and first index sum. At index 2 we have 0, 0, 1 and 2 index sum. So this way this is called running sum. So we will understand this and see how we can do this. So in this question, we are given an array nums and we need to calculate running sum. So for 0th index, we will have just sum of 0 elements, which is 1. For next index, we have sum of these two elements, which is 1 plus 2. For this index, we have 1 plus 2 plus 3. And for last index, we have 1 plus 2 plus 3 plus 4. So this is running sum. Now looking at this and thinking of naive solution, what we can do is that for every index I, calculate the sum of all elements from index 0 to I. For example, we are at this. If we calculate all the element sum from 0 to I, we will have output for this index. So this is the naive idea. For coding the naive idea, it's very simple. What we will do is we will have a loop and we will have a variable sum initially equal to 0, and what we will do is we will have an inner loop from 0 to I and we will add elements to the sum. This way, for answer of one index we will have answer in sum. This way we will do for all the indices and at last we will return answer. So the answer here is a vector. So this is a vector of size n. This way this is a naive solution. What we look at it for a very simple question, we used order of n square time complexity. So we need to think whether we can optimize this or not. So while looking for optimization, we can see that while we are moving forward, if we store the left sum and keep adding one element to the existing sum, this way we will have next element sum. We don't need this extra loop every time. So let's see optimization. So using prefix sum, what we will do is initially what we have is sum is equals to 0. We will add this element. So sum will become sum is equals to nums 0th element. Now we will run our loop forward and add next element to the previous sum. So this way sum will become 0th element plus first element. This way we will keep adding next element. So it's a very simple code. So in this what we are doing is we are modifying existing array. We have nums of I and we are modifying it to nums of I plus whatever is the previous one. So this way what it will become is initially for the first element it will remain same always. For next element what we are doing is this element plus the previous element. So this will make it 3. For next element what we will do is this element plus previous element, because this already has these two. So this way this will become 3 plus the previous element. So this will become 6. So for next element, this element which is 4 plus 6. So this will become 10. So we have this answer in the existing array and we can return this. If we want this to be in another array, we can do this that way also, but this case this will work fine. So we are modifying it in place. So this way we have time complexity of order n and we are not using any extra spaces instead of the given array. So now let's code this. So for this question, what we'll do is we will have a for loop from I is equals to 1 to I less than nums dot size and I plus plus. Now we will modify the existing array which is equal to nums of I plus nums of I minus 1. So we have I equal to 0, we have I equal to 1 initially, and this way this will become 0. So we will have first element ready. Similarly, this will move forward and at last we will return nums. So let's run this. So this was a simple question, but it lays a good foundation for prefix sum so that in future we can use it. So for more such videos, please subscribe to my channel. We will eventually level up on the prefix sum pattern.